Today we are going to start section 8.1, Functions. We've been leading up to this section in this chapter for some time to prepare ourselves for the graphing that you're going to need to do in Algebra 1. This section is going to discuss relations and functions. Recall that we learned what a relation was in section 1.6. A relation is just a set of ordered pairs. Well, a function is actually a special relation in which each member of the domain is paired with exactly one member in the range. Remember that the domain is the x values and the range is the y values. Look at the examples that I've provided for you. In the first example, we have the relation -10, -34, 0, -22, 10, -9, and 23. I've listed the domain, which is the set of x values, -10, 0, 10, and 20, and the range, -34, -22, -9, and 3. So you can see that each one of the members of the domain is paired with exactly one member of the range. So this relation is a function. In the second example, we have -10, -34, -10, -22, 10, -9, and 23. Once again, I've listed the domain, which is -10, 10, and 20. I didn't have to list -10 twice because it's already been listed, so we can just leave that off. And the range is -34, -22, -9, and 3. Notice that 20 is paired with 3, and 10 is paired with -9, but -10 is paired with -34 and -22. So this is not a function because the fact that -10 in the domain is paired with two different range values. As a tip, in general, if all of the x values in the relation are different, then it is a function. If any of the x values are the same, then it is not a function. Let's look at example 1, ordered pairs and tables as functions. Determine whether each relation is a function. Explain. In A, we have the ordered pairs 13, 5, -4, 12, 6, 0, and 13, 10. So this one is not a function because 13 in the domain is paired with 5 and 10 in the range. If you remember my study tip, I told you that if you have two of the same x values, then it's not going to be a function, as long as it is paired with two different y values, which it is in this case. In example B, we have a table showing the domain and the range. So we have -3 paired with 3, -1 is paired with -2, 0 is paired with 5, 1 is paired with -4, and 2 is paired with 3. None of our domain values are the same, so each member of the domain is paired with exactly one member of the range, and this is a function. Since this is such an easy concept, I don't think any of you will have a hard time understanding the concept of functions as it relates to determining whether a relation is a function. I'm going to have you go ahead and do self-check 1. Be sure to just show your answers on the note page. There's actually no work to show here, so I'll just need to see your answers. Another way to determine whether a relation is a function is to use the vertical line test. In the vertical line test, you'll use a pencil or a straight edge to represent a vertical line. Place the pencil at the left of the graph. Move it to the right across the graph. If for each value of x in the domain, it passes through no more than one point on the graph, then the graph represents a function. In example 2, if I were to move this pencil across the graph, this relation, represented by the graph, is a function because this pencil, or any other vertical line that you used, will not pass through more than one point on the graph at a time. Let's look at guided practice 2. Here we're going to use this graph to identify a function. Now, I can't actually show you moving my vertical line across the graph here, but if you were to stop what you're doing and take a pencil, pause this video for just a minute, take a pencil or a straight edge and move it across this graph, you would find that this is a function because your straight edge is not going to pass through more than one point at the same time. So yes, it is a function. Now you try. In self-check number 2, A and B, take just a second and use a vertical line, either a pencil or something else with a straight edge, and determine whether or not the relation represented by these two graphs is a function. All you're going to do is show your answer on your work paper, and or on your notes paper, there is no work to show. The last thing we're going to do in this lesson is describe a relationship. In example 3, we'll use a function to describe data. In this case, we're talking about the weather, so we're going to use the table that shows how various wind speeds affect the actual temperature of 30 degrees Fahrenheit. So in the table, we have wind speeds of 0, 10, 20, 30, and 40, and we have wind chill temperatures of 30, 16, 4, -2, and -5. In letter A, it says, does the data in the table represent a function? Well, yes, it does, because each wind speed is paired with exactly one wind chill. So, in other words, none of the numbers in our domain are the same. They're each paired with exactly one member of the range. In B, it says, describe how wind chill temperatures are related to wind speed. Well, I can see from looking at the table that as my wind speed increases from 0 to 40, my wind chill temperature actually decreases, it should say. So as the wind gets stronger, the temperatures decrease. Okay? Let's look at guided practice 3. In this case, we'll use the table that shows the number and size of farms in the United States every decade from 1950 to 2000. So we have the years 1950, 1960, 1970, 1980, 1990, and 2000. And we have the number of farms in millions. So we have 5.6 million, 4 million, 2.9 million, 2.4 million, 2.1 million, and 2.2 million. We also have the average size in acres of each farm. And in 1950 it was 213, 1960 297, 1970 374, 1980 426, 1990 460, and in 2000 it was 434. So in letter A it says, is the relation year to number of farms, so that's going to be year and number of farms, this is our first domain, or first domain and range, is that a function? And explain. So if I look at these two, I see 1950 is paired with one member of the range, 1960 is paired with one, 1970, 1980, 1990, and 2000. So, yes, this is a function because each year is paired with only one member of the range, or one number in the number of farms that were in the United States during those years. In letter B, describe how the number of farms is related to the year. Well, it looks like as the years increase, the number of farms decrease. For the most part, we have one little part where it goes up. But as we get further along in years, the number of farms has decreased. And I'm not going to write that because it would be hard to write with my stylus. In self-check 3, you're going to use this same table, only you're going to use the information that it requests. So in C it says, is the relation year to average size of farms a function? Explain. And in D, describe how the average size of farms is related to the year. So go ahead and do these on your notes page. Again, there's no work to show, so you'll just show me your answers.